300 feet of water, violent currents where two Great Lakes collide, ice flows that can crush steel like cardboard, and winds that had already destroyed one of America's greatest bridges. In 1957, engineers did something that experts said could not be done. They sank foundations deeper than the Statue of Liberty is tall. They anchored towers into bedrock that geologists warned was too weak to hold. They built the longest suspension bridge in the Western Hemisphere, across the most dangerous 5 miles of water in the Great Lakes. This is the story of the Mackinac Bridge, and why so many people were certain it would fail. Before we talk about how they built it, you need to understand what they were up against. The Straits of Mackinac is not just any body of water. It is the violent collision point between two of the largest freshwater lakes on Earth. Lake Michigan on the west, Lake Huron on the east. Together, these two lakes contain 21% of the world's surface fresh water. And all of that water has to pass through a gap that is only 5 miles wide. The result is chaos. Currents in the straits do not flow in one direction like a river. According to research from the National Oceanic and Atmospheric Administration's Great Lakes Environmental Research Laboratory, the water oscillates. It changes direction on average once every 1.5 days. Sometimes the flow moves east toward Lake Huron. Sometimes it reverses and pushes west toward Lake Michigan. And when conditions are right, that flow can move 80,000 cubic meters of water per second. That is more than 32 Olympic swimming pools every single second. Rushing back and forth beneath your bridge, the depths made everything worse. The straits plunged to nearly 300 feet in places. That is almost as deep as a 30-story building is tall, and the geology beneath that water was unlike anything bridge engineers had faced before. 11,000 years ago, retreating glaciers carved out the Great Lakes basin. As the ice melted, it left behind a complex underwater landscape. Beneath the straits lies a submerged river valley that was carved when water levels were much lower. That ancient valley cuts through layers of limestone, dolomite, shale, and other sedimentary rock. Some geologists warned that this rock was too porous, too weak, full of cavities that would collapse under the weight of a massive bridge. Building foundations here would not be like building on solid granite. It would be like building on Swiss cheese. And then there was winter. The Great Lakes freeze. The ice does not sit still like a frozen pond. In the straits, massive sheets of ice, 8 feet thick in some places, grind back and forth, pushed by wind, pushed by current, pushed by the constant oscillation of water between the two lakes. When that ice meets an obstacle, it does not stop. It pushes. Engineers had measured the force of Great Lakes ice for decades. The maximum pressure ever recorded in the field was 21,000 pounds per linear foot of pier width. Let me put that in perspective. 21,000 pounds is roughly the weight of 3 pickup trucks. Now imagine 3 pickup trucks pressing against every single foot of your structure, continuously, for months. Any bridge across the straits would have to survive that crushing force, every winter, forever. But the ice was not the only thing that could destroy a bridge. Wind could do it too, and engineers had just watched it happen. On November 7th, 1940, a suspension bridge in Washington state did something that engineers thought was impossible. It tore itself apart. The Tacoma Narrows Bridge had opened just 4 months earlier. It was beautiful, elegant. At 2,800 feet, it had the 3rd longest main span in the world. And it was extremely flexible. From the day construction began, workers noticed the bridge moving. When wind blew across the deck, the roadway would rise and fall in waves. Workers nicknamed it Galloping Gertie. The state told the public not to worry. The bounce was normal. Engineers were installing damping devices. Everything was under control. On November 7th, the wind was blowing at about 42 miles per hour. Not hurricane winds, not tornado winds, a moderate gale, but something was different that morning. The bridge started its familiar bouncing. Then, around 10 o'clock, something changed. The bouncing transformed into twisting. One side of the deck would rise while the other side fell. Then they would reverse, back and forth. The amplitude grew larger and larger. A newspaper editor named Leonard Coatsworth was driving across the bridge when the motion became violent. His car was thrown onto its side. He crawled on his hands and knees to safety, leaving behind his daughter's dog, a black cocker spaniel named Tubby. A professor named Frederick Farquharson, who had been studying the bridge's motion, watched in horror. He had seen this pattern in his wind tunnel models. He had warned that if the bridge ever started twisting like this, it would be the end. By 11:10 that morning, it was over. The center span ripped apart and plunged into Puget Sound. Tubby the dog went with it, the only casualty. But the real victim was the entire field of suspension bridge engineering. The Tacoma Narrows collapse became one of the most studied engineering failures in history. The footage of the bridge twisting and falling is still shown to engineering students today. The cause was something called aeroelastic flutter. The bridge had been designed with solid plate girders beneath the roadway, only 8 feet deep, extremely thin, extremely elegant. When wind hit those solid plates, it could not pass through. Instead, it created lift and turbulence. The deck started to oscillate. The oscillation created more turbulence. The turbulence amplified the oscillation. It was a feedback loop that fed on itself until the structure destroyed itself. The lesson was clear. Suspension bridges were not as safe as everyone thought. And if you were going to build one across a place as windy as the Straits of Mackinac, you were risking catastrophe. People had been dreaming of a bridge across the Straits since 1884. That year, a newspaper called the Lansing Republican reprinted a story arguing that Michigan needed a bridge or tunnel if it was ever going to have a great east-west route through the state. A store owner in St. Ignace reprinted an illustration of the Brooklyn Bridge in his advertising. He captioned it, "Proposed Bridge Across the Straits of Mackinac." It was wishful thinking, but the idea would not die. In 1888, Cornelius Vanderbilt II stood before the board of directors of the Grand Hotel on Mackinac Island and proposed building a bridge. He pointed to the Firth of Forth Bridge in Scotland, which was under construction at the time. If they could bridge the Firth of Forth, why not the Straits of Mackinac? Decades passed, nothing happened. In 1920, the Michigan State Highway Commissioner proposed a different solution, a floating tunnel. That idea went nowhere. An engineer from New York proposed an elaborate series of bridges and causeways that would hop from island to island, starting at Sheboygan, 17 miles southeast of Mackinac City, crossing to Bob Lowe Island, then Round Island, then Mackinac Island, then finally leaping across the deep channel to St. Ignace. That plan was rejected too. In 1923, the state gave up on finding a crossing and established a ferry service instead. Within 5 years, the ferries were overwhelmed. By the 1950s, 9 ferry boats were running constantly. They could carry up to 9,000 vehicles per day, and it still was not enough. During hunting season in November, the situation became absurd. Thousands of hunters from across Michigan descended on Mackinac City, desperate to reach the Upper Peninsula before opening day. Cars backed up for miles. Some reports said 16 miles. Drivers waited up to 24 hours just to board a ferry. 24 hours, sitting in your car, in November, in Michigan. Entrepreneurs walked the line selling hot pasties, sandwiches, candy bars. One man reportedly walked car to car with a jug of whiskey, selling shots for 25 cents. Everyone drank from the same glass. The state desperately needed a bridge, but the experts kept saying it could not be done. The depths were too extreme. The geology was wrong. The ice would crush any structure, and after Tacoma Narrows, the winds would tear it apart. Enter Prentice Marsh Brown. Brown was born in St. Ignace in 1889. He grew up staring across the straits, watching ferries struggle through ice and fog. As a young lawyer, he served as prosecuting attorney of Mackinac County. During one especially brutal winter, he missed an important argument before the Michigan Supreme Court. The ferry could not run. The straits were choked with ice. So Brown did something desperate. He walked across, on foot, across the frozen straits. That bitter hike would haunt him for the rest of his life. Brown went on to serve in the United States Congress and the Senate. He ran the Office of Price Administration under President Franklin Roosevelt. He became chairman of Detroit Edison, but he never forgot that walk across the ice. In 1950, Brown was appointed chairman of the new Mackinac Bridge Authority. He was 61 years old. He would spend the next 7 years fighting for a bridge that Wall Street said was impossible to finance. The problem was money. Not engineering, money. The bridge would cost nearly $100 million in 1950s money, equivalent to roughly $1 billion today. The state of Michigan refused to risk taxpayer money on the project. They would contribute exactly $1, one single dollar. The rest would have to come from bonds that would be repaid with toll revenue. But when the Mackinac Bridge Authority approached Wall Street, the biggest investment houses laughed. "You want us to loan $100 million to build a bridge between two communities with a combined population of less than 4,000 people in one of the most remote corners of the Midwest? No, thank you." The first bond attempt failed. The second attempt failed. By June of 1953, it looked like the project was dead. The state legislature had given the Bridge Authority until December 31st to secure financing. If they failed, the deal was off. Everyone assumed it was over. Everyone except Prentice Brown. In October, a vice president at a small investment firm called Allen & Company attended a World Series game at Yankee Stadium. He heard that the Mackinac Bridge Authority was desperate. By November, he was sitting at a table at the Drake Hotel in New York with $500,000 in earnest money and a plan. By the end of the year, investors across the country had purchased $99,800,000 in Mackinac Bridge bonds. Construction could finally begin. But who would design it? After Tacoma Narrows, the question of who would engineer a massive suspension bridge was not trivial. The designer of Galloping Gertie, Leon Moisseiff, had been one of the most respected bridge engineers in the world. He had worked on the Golden Gate Bridge, the George Washington Bridge. After Tacoma Narrows collapsed, his career was destroyed. The Mackinac Bridge Authority needed someone who understood why Tacoma Narrows failed. Someone who could design a bridge that would never suffer the same fate. They found David Barnard Steinman. Steinman was born in 1886 in a tenement on the Lower East Side of Manhattan. His family had almost nothing. As a boy, he sold newspapers in the shadow of the Brooklyn Bridge. He would look up at that massive structure and tell his friends that someday he would build bridges just like it. They laughed at him. Steinman worked his way through City College, graduating summa cum laude. He earned a Ph.D. in civil engineering from Columbia. His doctoral thesis was a design for the Henry Hudson Bridge. More than 20 years later, he actually built it. By the time the Mackinac project came along, Steinman had designed over 400 bridges on 5 continents, and he had spent years studying why suspension bridges fail. Here is the crucial detail. Steinman had predicted the Tacoma Narrows collapse before it happened. Years before Galloping Gertie opened, Steinman published warnings about the dangers of building suspension bridges with shallow, flexible decks. He argued that solid plate girders were dangerous, that they acted like sails in the wind, that they could create the kind of oscillation that would tear a bridge apart. The designers of Tacoma Narrows ignored him. After the collapse, Steinman published a series of articles explaining exactly what had gone wrong. He developed mathematical principles for aerodynamic stability in suspension bridges, principles that would guide bridge design for decades. Now, at 63 years old, he had a chance to prove his theories. The Mackinac Bridge would be his masterpiece, Steinman's design attacked every problem that had killed other bridges. First, the wind. Tacoma Narrows failed because solid plate girders acted like sails. Wind hit them, created lift, and the deck oscillated until it ripped apart. Steinman used open stiffening trusses instead, deep, heavy, 68 feet wide, full of gaps that let wind pass through instead of pushing against the structure. But he went further. The center lanes of the roadway were built with open steel grating, not solid pavement. Wind could blow straight through the deck itself. Steinman calculated that his design could withstand a theoretical critical wind velocity of 642 miles per hour. Let me say that again. 642 miles per hour. For reference, the strongest tornado ever recorded had winds around 318 miles per hour. The highest wind speed ever measured on Earth's surface was 253 miles per hour on Mount Washington. Steinman designed his bridge to survive winds that do not exist. The bridge was not just safe. It was over-engineered to an almost absurd degree. And that was exactly the point. After Tacoma Narrows, no one would ever question whether the Mackinac Bridge could survive wind. But the wind was only half the problem. The foundations had to survive something worse, the ice, and the depth. The main tower piers had to be sunk into bedrock more than 200 feet below the water surface, 200 feet. The South Tower Pier sits in water that is 210 feet deep. To put that in perspective, the Statue of Liberty from base to torch is 305 feet tall. These foundations went almost as deep underwater as Lady Liberty is tall above ground. That is what your thumbnail is showing. A concrete pier descending into darkness, with the Statue of Liberty beside it for scale. The piers were the deepest structures ever sunk in suspension bridge construction. Nothing like them had ever been attempted. The contractors knew this would require unprecedented equipment. Merritt Chapman and Scott Corporation won a $25 million contract to build all 33 marine foundations. They assembled the largest bridge construction fleet in peacetime history. Barges, cranes, derricks, pile drivers, floating platforms, all converging on the straits from ports across the Great Lakes. The work would require divers operating at the very edge of what 1950s technology could safely achieve. Deep water diving, limited visibility, crushing pressure, water temperatures that could kill. Construction began on May 7, 1954. The first challenge was sinking the massive caissons. Caissons are double-walled, watertight cylinders that form the foundation of the piers. Each section was 44 feet tall and 116 feet in diameter. They were fabricated off-site, floated into position, then carefully sunk through the water, through the mud, through the sand and clay, all the way down to bedrock. 100 feet down in some places, deeper in others, Frank Pepper was 46 years old. He was one of the divers working on the foundations. On September 16, 1954, Pepper was working at a depth of 140 feet. When he surfaced, he came up too fast. By the time they rushed him to a decompression chamber, it was too late. He died from the bends. Frank Pepper was the first of 5 men who would lose their lives building the Mackinac Bridge. 3 weeks later, a 26-year-old welder named James Lesarge lost his balance and fell into a caisson. He dropped 40 feet, striking the crisscrossing steel beams inside. He died from head injuries. 12 days after that, a 40-year-old worker named Albert Abbott fell just 4 feet into the water while working on a narrow beam. Witnesses believe he may have had a heart attack. He drowned. The most tragic day came on June 6, 1956. 2 iron workers, 28-year-old Jack Baker and 28-year-old Robert Coppin, were working on a temporary catwalk near the top of the North Tower. It was their first day on the job. The catwalk collapsed. Both men fell 550 feet into the straits. Baker's body was recovered immediately. Coppin's body was never found. A 3-day search turned up nothing. Contrary to popular legend, no workers are buried in the concrete of the Mackinac Bridge, but Robert Coppin's remains are somewhere beneath those waters. A memorial near the bridge honors all 5 men. Once the foundations were complete, the towers rose. Each tower stands 552 feet above the water. That is 55 stories tall, taller than most skyscrapers in Michigan. The towers were assembled from 40-ton steel sections fabricated in Ambridge, Pennsylvania. Each section was 16 feet tall. Workers used derrick barges and a device called the creeper to hoist the sections into position. Individual pieces weighed up to 280 tons. The workers operated without safety harnesses, without nets, without most of the safety equipment that would be required today. They bolted and riveted the sections together using a total of nearly 5 million fasteners, 4,851,700 rivets, 1,016,600 bolts. Jim Sweeney was the boss of a rivet gang, the first rivet gang to work on the bridge. Years later, he admitted that he pulled rank to drive the first rivet himself. The rivet boss, he said with a smile, has an argument that he should be the first. The ironworkers came from all over the country. Many of them were veterans of other major bridge projects. They worked through bitter cold, high winds, fog, and rain. When the straits were too rough for supply barges, they improvised. Jim Burwell, an ironworker, later recalled that carrying drinking water up to the work site was such a burden that men started tying lines to buckets and dipping them into the straits far below. The water, he said, tasted fine. Sometimes fog was so thick that workers could not see the water below. They would lower their buckets anyway. More than once, Burwell said, you would hear bang bang and you knew the bucket hit a ship below. Sound traveled really good. Oh, the cussing and swearing you heard from down below. You could not print what they said. The cables came next. The 2 main cables supporting the suspension span are 24.5 inches in diameter. Each cable contains 37 strands. Each strand contains 340 individual wires. The total length of wire spun together to form those cables is 42,000 miles, enough to wrap around the Earth 1.5 times. Workers spun the cables using a system of spinning wheels that laid down 4 wires at a time. The wire came from 16-ton drums containing 300 to 20,000 feet of wire each. When the spinning was complete, the cables were compressed and wrapped in protective coating. The approach spans required 35 deck truss sections. The suspended portion alone stretched 8,614 feet from anchorage to anchorage, longer than the Golden Gate Bridge, longer than any suspension bridge in the Western Hemisphere. The entire structure stretched 5 miles from shoreline to shoreline, 26,372 feet, just 28 feet short of 5 full miles. Construction took 42 months, 3.5 years, 4 summer construction seasons with no winter work. The project required 3,500 workers, 350 engineers, 7,500 additional workers in quarries, mills, and fabrication shops across the country, 895,000 blueprints and structural drawings, 71,300 tons of structural steel, 931,000 tons of concrete, 268,000 cubic meters of that concrete was poured underwater. The 2 main cables used 60,000 coils of wire. Each coil was spliced to create 60 miles of continuous wire on each reel. Each reel weighed over 19 tons. The total cost was $99,800,000, almost exactly $100 million in 1957 money, equivalent to roughly $1 billion today. On November 1st, 1957, the Mackinac Bridge opened to traffic. Governor G. Menon Williams paid the first toll, $3.25. An hour later, he rode on the very last ferry crossing the straits. The ferry service that had operated for 34 years was finished. The 24-hour waits were over. The 16-mile backups were history. Michigan was finally one state. The dedication ceremony was postponed until June of 1958 because organizers expected bad weather in November. Ironically, the June celebration was marred by fog and rain anyway. The United States Postal Service issued a 3-cent commemorative stamp. It was titled, "Connecting the Peninsulas of Michigan." Over 107 million copies were printed. The bridge David Steinman built has now stood for nearly 70 years. It has survived winds exceeding 78 miles per hour. It has survived winter after winter of grinding ice. It has survived everything the Great Lakes could throw at it. The ice pressure that engineers feared has never come close to threatening the structure. Remember, the maximum ice pressure ever measured was 21,000 pounds per linear foot. Steinman designed the piers to withstand 115,000 pounds per linear foot, a safety factor of 20. The bridge has never been seriously tested. David Steinman died on August 21, 1960, just 3 years after his masterpiece opened. He was 74 years old. He never got to build his ultimate dream project, a bridge across the Strait of Mackinac connecting Sicily to mainland Italy. But he left behind something that proved his theories correct. The Mackinac Bridge was designated a National Historic Civil Engineering Landmark by the American Society of Civil Engineers in 2010. It was the youngest bridge by far to receive that honor. Every other bridge on the list dated to before 1940. Prentice Brown, the man who walked across the frozen straits and spent decades fighting to build the bridge, remained chairman of the Mackinac Bridge Authority until his death in 1973. He was 84 years old. He is buried in St. Ignace, the town where he was born, the town he could finally reach without waiting 24 hours. According to the original designers, if properly maintained, the Mackinac Bridge will last another 1,000 years. It has already carried over 150 million vehicles across the straits. It still carries roughly 11,000 vehicles per day. Every Labor Day, the governor of Michigan leads tens of thousands of people on the annual Mackinac Bridge Walk, a tradition started by Governor Williams in 1958. Some people are still afraid to drive across. Bridge workers call them Timmies. In extreme cases, bridge personnel will drive a nervous motorist's car across for them. About 1,000 people per year request this service. The next time you see a photograph of the mighty Mac, think about what is hidden beneath the surface. Foundations sunk deeper than the Statue of Liberty is tall. Piers armored against ice pressure that has never come. A structure designed by a man who grew up in a tenement selling newspapers under the Brooklyn Bridge, who told everyone he would build something great someday, and who did. They said it was impossible. They were wrong.